So first topic up is ratio, proportion, and variation. Now, most ratio proportion questions will give you data in terms of ratios. This is something that can happen across topics as well. So it need not be a ratio proportion question only. It could be a TSD question as well, and they can give it to you in terms of ratio, the speeds, distances, times, etc. So the number one thing to do in this situation is, if they say that the ratio is 3 by 5, you assume the variables, whatever they are. Let's say they say ratio of A by B is 3 by 5. You assume that A is equal to 3x and B is equal to 5x. And then you use these 3x and 5x in the further equations that you will form. Now, secondly, very often what happens is that there is some initial condition, and let's say the values are a naught and b naught in the initial condition. Then the values are a1 and b1. What they will give you is, they will give you what this value is, the ratio of these values, and then they will give you the values of these ratios. A naught by b naught they will give you, and a1 by b1 they will give you. Now, to connect to ratio inputs, they will have to give you some uh, absolute data, addition, subtraction, etc. They will have to give you. So they might say something like the ratio was 3 is to 5, and then A gave some of his items to B, and the ratio changed to 2 is to 7. All right. So whatever he must have given is, let's say, what they are asking you to find. Okay, and let's say they have also given you some additional data point. We are still going to follow the same thought process. We will say that this was 3x and 5x, and this was 2y and 7y. And then we will say, let's say he gave a amount. So this changes to 3x minus a, which becomes equal to 2y, and 5x plus a becomes 7y. All right, and when you take the ratio, y will cancel out. You will then get 3x minus a upon 5x plus a is equal to 2 by 7. Or more importantly, you will get a as a proportion of x, which is probably what they will ask you for. So the method does not change. Usually, you will have two different ratios given, initial condition and a final condition, and there would be some absolute relationship in between them. So the idea is, we will convert everything into x and a's. All right, so by assuming ratios we can solve a lot of stuff. Moving ahead, now there is something called as ratio scaling, and this is a very specific sort of information. What they can do is, they can give you two separate ratios. Let's say they give you a is to b is to c as the scores of let's say three people. Then they give you a comparison as d is to e is to f, and then they will say that the value corresponding to c and the value corresponding to d actually belongs to the same person. All right. So you have one ratio input, you have another ratio input, and then they say that between these two ratios, there is a common link, and that is this value. So, for example, let's say they give you 1 is to 2 is to 3 is, a score ratio of people A, B, and C. And the score ratio of C, D, and E is, let's say, 6 is to 7 is to 8. Now they can then ask you what is a ratio of A and E. Now A is in this position and E is in this ratio. This is E, this is A. You can't directly compare that, which means that you will have to bring these two ratio data points that they have given to you into one common ratio. So this 3 can become 6 if you multiply this entire thing with 2. So 1 is to 2 is to 3 is the same thing as 2 is to 4 is to 6. And now because 6 is equal to 6, I can merge these two and say that A is to B is to C is to D is to E is 2 is to 4 is to 6 is to 7 is to 8. So 2, 4, 6, 7, 8. This is what has to be done. Now obviously I've taken a more simple value just for demonstration. 3 and 6, it was very easy to see that you have to multiply with 2. However, the idea remains the same. You have to multiply with something so that the common link between the two ratios, which is C and D, turns out to be equal. And what is that common value going to be, which puts C and D equal to each other? The LCM of C and D. All right. Great. Now, the a very specific sort of question in the ratio proportion topic area is population split. So you can have certain factors describing a population. For example, you can have a population getting described by gender, let's say male and female, and also by their age, youngsters and old people. Then they can give you certain inputs about, let's say, ratio of young males to young females is 3 is to 5, which means you will put 3x here and 5x here. Then they could have given you that the ratio of young males and old males is 2 is to 3, which means 3x corresponds to 2. So what should 3 correspond to? 3x by 2 into 3, or 4.5x. So using this, making a table helps organize the data in a very structured way, because when you are describing the population, you will be in a situation where there will be multiple statements, because you have four different intersections of the factors: young males, young females, old males and old females, and you could have data point regarding each of these four intersections. Furthermore, you could also be given total value of the males, which would come here as 3x plus 4.5x, which is 7.5x. You could also be given the total value of youngsters, which would be 8x. So using that, you can get your x, and then if they are asking you for any particular value, you can find that. So making a table helps you sort through your data in a population split category much easily. Moving on to the final part of this topic area, which is the variation part. So what does variation mean? So if I say that A varies directly with B, what I'm trying to say is that A is equal to B times some variable K. All right. If I say that A varies inversely with B, which I will write as this, I will say that A is equal to K by B. Now, K can be positive, K can be negative. Now, if K has to be negative, let's say K has to be negative, what will they put in the problem statement? That A decreases proportional to B, which would give you the idea that K has to be negative. And when you have a decrement scenario going on, you will have to assume that there has to be some initial value as well, which you will write here as plus C. So the total value that you will write is A is equal to C minus some, positive number. I'm writing it as mod K, but you understand, because this is a decrement situation, I can write it like this into B. So as the number of items B increases, the value of A will decrease. And initially, what should be the value of A? It should be C. So if you don't write this C in a decrement scenario, you will end up with results that will not make any sense. And in real time, that correction is going to be very difficult. So you have to make that choice. So the best way to understand if I should put a C or I should not put a C is understand if when B is equal to 0, will A be equal to 0? And this is the same thing we do with equations, right? This is what? This is a straight line equation. Y is equal to mx plus C. If value of B as 0 can give you the value of A as 0, then there is no need of C, because B equal to 0 will mean this is 0, and since A is 0, C will also have to be 0. So sometimes these are things that you will have to figure out on your own. For example, if I say, and this is a very common example I think you have seen in mocks, speed of a train decreases proportional to number of carriages attached to that train. So does common sense dictate that when there are zero carriages, speed of the train would actually be highest? Yes. So if in this particular scenario where I'm saying speed of a train decreases proportional to the number of carriages, if you had assumed that the speed is going to be, k times number of carriages, Are you not saying that when I put number of carriages as 0, then speed will be equal to 0, which makes no real sense. So generally when you have decreasing proportionally sort of situation, you will put a constant c, and then your actual speed would be, your actual expression for this particular statement should have been speed is equal to some initial speed, which is your, zero case situation, minus k times number of carriages. This is the expression you will write. And once you write these sort of equations, these proportionality equations, the question comes down to finding the constant of proportionality, which is the value of k. And then if they give you different set of inputs for number of carriages, you can find the corresponding speed as well. Are we clear on all of the things that we have discussed so far? All right, great. With that, let us move ahead. Let us look at some questions. A fruit seller has 187 fruits consisting of apple, mangoes, and oranges. The number of apples to mangoes is 5 is to 2. So I will write this as 5x and 2x. There is no information given here about oranges. So let me just write it as y. An equation that I directly have is 7x plus y is equal to 187, because these are the total fruits and this is your initial condition. After this person sells 75 apples. So how many apples will remain? 5x minus 75. How many mangoes will remain? 2x minus 26. And half of the oranges are sold, which means y by 2 oranges will be left. This is your final situation. I need to find the values of x and y. I so far only have one equation, which means I need an additional equation because I have two variables. And where is that additional equation? Ratio of number of unsold apples to number of unsold oranges is 3 is to 2. So this is unsold apples, this is unsold oranges, which means unsold apples is 5x minus 75 and unsold oranges is y by 2, and this becomes 3 by 2. And here you will have your second equation involving x and y. So you had x here. You will not directly get the ratio of x and y because of this 75 here, but you will get a linear equation in x and y. Second equation, two variables, two equations, we'll be able to find the values of x and y from here. Do you see what we actually did? We had this as some ratio, and there was some other ratio given to us, and there was some addition, subtraction, some absolute data change happening. Selling of 75 apples, selling of 26 mangoes, selling of y by 2 oranges. So I put those here, assumed the values, and then equated the new values to the new ratio that we have. You can after this solve and you will get 66 as your answer. The total number of unsold fruits is what you have to find. So that is 7x minus 75 plus 26, which is 101 plus y by 2. So this is what you have to find. Okay, great. Now let's talk about ratio scaling. There are five companies given to us. Profit made by C1, C2, C3 is 9, 10, 8. So I'll write this as 9x, 10x, and 8x. Profit made by C2, C4, and C5 is in the ratio 18 is to 19 is to 20. So this was C2. So 18y is to company 4 is 19y and company 5 is 20y. This is what is given to me. Now, if C5 has made a profit of 19 crores more than C1, now they are giving me data point for C5 and C1, which are currently not in the same, same ratio line, which means I have to convert this into this. And what is the common link here? C2. So what will I put as the common value? I will put the common value as what? 90. The LCM of 10 and 18 is 90. So let's forget these x for now. Okay. So to make this as 90, I'll have to multiply with 9. So 81 is to 90 is to 72. Now C2, this equation I will multiply with 5. Correct? So 5 into 18 will give me 90, which I have already taken care of. This becomes 80, this becomes 19 into 5, that is 95, and this becomes 20 into 5, that is 100. These are the ratios that I am given. And now I can find 18x, 100x. So 100x minus 81x is equal to 19x, which is given to me as 19, which means all of these are 1. 81, 90, 72, 95, and 100. So the profit made by all five companies is going to be the addition of these numbers itself, because x is turning out to be 1. And you will get your final answer as 438 from this. Clear so far? Okay, great. Then let's look at a population split example. Ratio of number of males and females is 5 is to 4. Ratio of number of literate males to literate females is 2 is to 3. So let us make the table. We will have to make the table male, female, literate, illiterate. Now, number of males to number of females is 5 is to 4. Now, because this is a total statement, I will not write the variables just now. I'll just write a small 5 is to 4 here. Okay. Uh, Number of literate males to number of literate females is 2 is to 3. So this is 2x, then this will be 3x. Number of illiterate males to illiterate females is 4 is to 3. So this becomes 4y and 3y. Now I can solve this. I can get the ratios of 2x of x and y. Why? Because this sum is going to give me males, which is 2x plus 4y. This is going to correspond to 5. And this sum will give me total females, which is 3x plus 3y, which should correspond to 4. This will give me the ratio of x and y. Also, one more thing that they have given you is 3600 males in the village are illiterate. So 2x is already given to you as 3600. So you can now substitute the values of x, or you can first find the ratio of x and y, because the final thing they are asking you is total number of females, which is going to be 3x plus 3y. Final thing, the variation issue. The price of a precious stone is directly proportional to the square of its weight. So the price is going to be k times weight square. Now tell me, should I put a constant here or not? Will a precious stone have some price if the weight is 0? If the stone does not exist, would there be any price? No, right? So I don't need to add a constant here. Secondly, this is not a decrement situation. All right. So Sita has a precious stone weighing 18 units. If she breaks it into 4 pieces with each piece having distinct integer weight, then the difference between the highest and lowest possible value of the total price of the 4 pieces will be 288,000. Then the price of the original precious stone is. All right, so obviously this is a CAT 2023 question. So this will require cases. So your total weight is 18 units. So you will say that your price is 324k. Now this you will break into A plus B plus C plus D, which becomes equal to 18 units. Now all of these have distinct integer weights. All right. And different between the highest and the lowest possible values of the total prices of the 4 pieces will be. Now, to increase the price, you will keep one of them to be the highest. All right. You will try and have as much disparity in the weight as you can. So, the highest value you will get corresponding to 1, 2, 3, and fourth one is 12. The lowest weight you will get when these are as close as they can be. You will have to keep it 3, 4, 5, 6. Correct? So you will get the value here in terms of k. You will get the value in terms of k. When you take the difference, you will get this as your answer. And that will give you the value of k, which you can then substitute back here and get your price. So again, as I told, the whole agenda is to get this proportionality constant value, and generally the final ask is something which relates to this proportionality constant. Yeah, so this is a good question, because this aspect and this aspect is something which, this is sort of a derivative of AMGM, but not directly. All right, let's move forward. Percentage changes and percentage change graph. So if this is a value x and this is increasing by a percentage, what will be the final value. The final value will be x times 1 plus a%. If it's a decrement, a would be negative, so you will put a negative value here. If it's an increment, a would be positive and this will increase. The percentage sign here stands for 1 by 100. If you are given successive changes, x increases by a%, then it decreases by b%. I am putting b as positive and giving you an additional minus sign. Then it again increases by c percentage. If I ask you for final value, there is a way to avoid calculating these intermediate values by writing this as x into first step 1 plus a%, second step 1 minus b%, and third step 1 plus c%. This is all there is to percentages in addition to ratio proportion. So most percentage questions overlap with ratio proportion as well, because I could have given you, for example, I could have given you these data point to you as percentages also. I could have said that literate males are 40% of all literate population. So that's up to you to decide that this is 2 is to 5 or 2x 3x. So the only novel thing which is happening in percentages is this percentage change graph. Let's say they give you x increases by a% and gives you y. Now instead of giving you this a%, let's say they ask what should y be decreased by to give you x. Correct? This is what you are saying. Final value is given and you have to find this percentage. So again, you can do that because percentage change is final minus initial upon initial. So in this equation, the percentage change will be a% is equal to final value y minus initial value x divided by x into 100. Whatever this ratio is, you multiply this with 100 to accommodate for the percentage sign. All right. If this is the situation, let's say this is b%, so what you will write is b% is equal to x minus y upon y, because in this change scenario, x is the final value, y is the initial value, so the percentage change is going to be x minus y upon y into 100. Now the numerator is same in magnitude for both of these. Correct. So the only change that these two have is of x and y. Now if x is smaller and y is bigger, basically if a is a positive number, then wouldn't this percentage be higher than this percentage? Because this is y minus x by a smaller number, while this is y x minus y, which is again y minus x negative divided by y, which is a bigger number. So if I give you 100
नहीं है
and I say
नहीं
that
अच्छा
this
लगा
increased
तो
by
मैंने ले
10%,
हाँ ले लिया
Sanjay,
भाई
can you mute? Yeah. So if you have 100 and it has increased by 10%, you will get 110. All right. Now, if I say what should be the percentage change to get back to 100, it's going to be 100 minus 110 divided by 110, or 1 by 11 into 100, and which is going to be 9.1% minus. So, the magnitude of percentage change has decreased because the base has increased. All right. Can we move ahead, folks? Okay, great. Salaries of three friends, Sita, Geeta, and Meeta, are in the ratio 5 is to 6 is to 7. So, this is again, as you can see, this is a ratio plus percentage question. They are very often asked, together. So, Sita, Geeta, Meeta, 5x, 6x, 7x. In the first year, they got salary hikes of 20, 25%, and 20%. So, this becomes 5x into 1.2. This is the 1 plus 20%. This is 6x into 1.25, and this is 7x into 1.2. In the second year, Sita and Meeta get salary hikes of 40 and 25. This is your successive change. This becomes 5x into 1.2 into 1.4, and this becomes 7x into 1.2 into 1.25. Now they are saying that Gita's value is the mean of this. Now they are saying salary of Geeta becomes equal to the mean salary of the three friends. We are clever enough to understand that it doesn't matter. What they are really saying is SGM are in AP. So this will be arithmetic mean of this and this. So you find this arithmetic mean, it will come in terms of x, and you have this initial value, this is your final value, they are asking you for the percentage change, so that you can directly calculate from here. If you want, you could have assumed these as 500x, 600x, and 700x. That would have helped you get rid of the decimals, but honestly, again, it's up to you because you still do have to do the multiplication. So this is going to be 9.45x, half of this plus this. Correct? I think this turns out to be 10.5, if I'm not wrong. 7 into 1.2 is 8.4, and 8.4 uh, quarter is 2.1. So that is 10.5. And this will turn out to be 6 into 1.4, which is 8.4. So 18.9 half is going to be 9.45. And this is 6x into 1.25, that is 7.5x. So your answer will be 1.95x divided by 7.5x in 200. Correct? So you can get your answer here as 26%. Up to you, you can go with 500x. It will make your calculations faster. Okay, moving on. Next question. Right? So we even, if you sort of see that we sort of, made a table here as well. So again, application wise percentage and, ratio proportion, a lot of the things are common. Moving on. Total male female in 1970 to 1980, 1980 to 1990. So I already see that there are three periods given to me, 70, 80s and 90s. So I would want to make some sort of a timeline. So let me make it 1970, 1980 and 1990. Now I have males and I have females. Total male and female population in a city increased by 25%. So let me say initially this is M and F. So total increase by 25%. So the increment is 0.25 times M plus F. Again, you could have taken M and F as 100 M and 100 F, but I generally prefer these decimals because I don't want to add extra space. It's up to you. During the same period, the male population increased by 40%, while the female population increased by 20%. So, this total increment in your number is actually coming from zero point 0.4 times M, 40% increment in M, plus 20% increment in F. This is an equation which gives you F is equal to 3M. So, you have gotten the ratio of males and females in the initial scenario. This becomes 3M. Now, this increased by what? 20%. So this became 3.6M. 3 into 1.2. All right. Now, what more is given to us is from 1980 to 1990, the female population increased by 25%. So this will further increase by one fourth. 25% is one fourth. One fourth of 3.6 is zero point 0.9. So this becomes 4.5M. In this scenario, the population of females is twice the male population. So the male population will be half of this, which is 2.25M. The percentage increase in the total of male and female. So initial total was 4M. The final total is 6.75M. Correct? So the percentage increase from 1970 to 1990 is 2.75 divided by 4. Correct? Which will come out to be 68.75%. So this is pretty much it. Two percentages plus ratio proportion. They are for your purpose, one and the same thing only. So this, if you look at it, what they have really done is from one ratio to another, instead of giving you absolute data, they gave you the percentage increment. So ratio proportion plus percentage marriage happens like this. You have one ratio, you have another ratio. Instead of giving you an absolute value here, they give you the percentage increment. So what have these increased as a ratio?